Hey parents, Ms. Carp here. This is video 2 for 11.5. Again, partial fraction decomposition, repeating linear factors. This is again case 2. If you want to work this one out on your own, press pause and then you can keep going and check and see how you're doing. I'm going to do this one a little bit differently. I'm going to do this one by setting up systems of equations. So it's going to start off the same. So the first thing I'm going to do is I'm going to have a over x plus b over x squared plus c over x plus 1. This is your repeating linear factor. This is a repeat of that. Because this is a repeat of something linear, this does not make it a quadratic. Let me say that again. This is repeating linear, okay? All right, so this is what I have, and I'm going to do my fraction bust. So I'm going to get 2x plus 3 equals ax times x plus 1 plus b times x plus 1 plus c times x squared. So doing the fraction bust, I remove that, right? What's in the denominator, and I've got these values now. We can go through and say let x equal 0, let x equal -1, and then we can let x equal something else. I know you're good at that. You can pause this and you can finish it from here if you would like. All right? So what I'm going to do is I'm going to set this up a little bit differently. All right? So I'm going to go ahead and multiply these out. And I have ax squared plus ax plus bx plus b plus cx squared. And then I'm going to regroup this. All right, so this side is still the same, 2x plus 3. So I'm going to regroup these so that the x squareds are together. Okay, so I'm going to have ax squared plus cx squared. Then I'm going to regroup the x's. So ax plus bx. And then I'm going to have just this one. I only have one that's a constant, okay? So please notice, this is the x squares, this is the x's, and this is the constants, okay? And again, this is just a different way of doing the same thing. So on this side, what are the x squares? And you would say, Ms. Carp, there are none of them. There's 0. So since there's 0x squared, we're going to put a 0 here. How many x's are there? Well, there's 2 x's on this side. And how many constants? There's 3. So that's what we have. So now notice that I can factor out the x's. So I could actually write this way. I could write this as 0x squared, 2x, and 3. So if I factor out the x squares, they would cancel out. If I factor out the x's, those would all cancel out. And there isn't anything to factor out here. So I already know that b is equal to 3. So I have these two equations. I have 0 equals a plus c. And I have this equation, which is 2 equals a plus b. But I already know that b is equal to 3. So I can do back substitution. So we're going to take this 3, put it in there. Okay. So I have 0 equals a plus c. I have 2 equals a plus 3 because I back sub the b. So then if I subtract this, I get a equals -1. I already have b equals 3. And if I take these and now back sub into this, I get 0 equals -1 plus c. So I can tell now that c is going to equal +1. So let's finish the problem by setting up our partial fraction decomposition. So we have a is -1, and that was over x. B is 3, and that was over x squared. And c is 1, and that was over x plus 1. There you go, Barons. Different way doing the same problem. Happy mathing.